fascicles, or bundles of myofibers. Within each myofiber are myofibrils, and within each myofibril are myofilaments. Throughout the entire muscle, you can find mitochondria. Today I will be explaining a muscle contraction. An action potential travels down the axon, opening up calcium channels and allowing calcium to flow into the axon and down to the synaptic knob. At the synaptic knob, calcium pushes synaptic vesicles containing acetylcholine down to the rest of the way of the synaptic knob, where acetylcholine is released into the synaptic cleft. Acetylcholine binds to the motor end plate, opening up sodium-potassium channels and allowing sodium and potassium to flow into the muscle fiber. This depolarization causes another action potential which travels down the sarcolemma and into the T-tubules, where it stimulates calsequestrin to release calcium. The calcium floods out of the sarcoplasmic reticulum and into the sarcomere, which is the basic functional unit of a muscle contraction, containing thick and thin filaments consisting of the I-band, A-band, H-band, and Z-disc. Calcium floods over the thin filament, binding to troponin. This bind stimulates tropomyosin to turn, revealing the active site underneath actin. High-energy myosin then leaps to actin and binds there. Okay, the myosin head, once it binds to the active site, goes into a low-energy state, releasing ADP and causing the thin and thick filaments to shift over each other. ATP binds to the myosin head, causing the myosin head to break free from the active site on the actin. The myosin head becomes energized once again as ATP is converted into ADP. Calcium is pumped back into the sarcoplasmic reticulum and attached to calsequestrin, allowing the thin filament to return to its original state and close the active sites. Acetylcholine esterase is released into the synaptic cleft, closing the sodium-potassium channels and breaking acetylcholine into acetic acid and choline, which is brought back into the axon knob, and eventually will be stored into synaptic vesicles again, which ultimately results in muscle relaxation.